Exercise 10I, page 454. Okay, 4. What we need to do is to take the derivative of this. We're doing that. We've got 20. The derivative of sine is cosine, and the derivative of what's inside there is 1 on x. That comes down to that. Okay, so what we need to do, the first step is to find the derivative. The second step is to find the smallest positive value of x for which that function equals its derivative. So we equate them both here. On the left-hand side, we've got the original function. On the right-hand side, we've got the derivative. Okay, we move things around a little bit. We get rid of the 20s. We've got sine log of x equals cosine log of x, natural log of x on x. And then we put sine log of x, bring the cosine over here, and that equals 1 on x. It's 1 on x. And then sine over cosine is tan, so tan of log of x equals 1 on x, and then we use our GDC, numerical solve, nsolve, to find the answer. And to 3 significant figures, the answer is 0.175. Let's have a look at B. Okay, we're finding the derivative of this. It's 1 over this function here. Be careful, that's not cosine x plus 2, it's cosine x plus 2, right? They're not together, those two. Be careful here. The derivative of cosine x is minus sine x, so that's minus sine x over cosine x. Okay, and then another term is plus 2. Now we have to equate the two. The second part asks us to put the function, equate that to the derivative, and to find the smallest possible positive value of x. So put them together. On the left-hand side, we have the original function. On the right-hand side, we have the derivative, and we're going to use the calculator. So let's watch that, shall we? Now, with the calculator, obviously, you go to the graph function. Now, this calculator has a bit of issue with caps for some reason, this emulation software. But we're going to put in one of the functions. We're going to see so much more when we use the graph to solve this than to using nsolve. Okay. So we're going to put the left-hand side in, and we're going to see what that looks like. Okay, this does have a few issues, these buttons here. My trig button sometimes doesn't work. So we've got that, okay, and that's the first function. Now we're going to put in the right-hand side. Normally I would use the fraction button here, but it doesn't seem to work. Watch what happens when I give it a bit of a push here. Put the second function in. It goes a bit weird. So we'll go back to it, and I'll use just brackets and the division sign to put it in. Okay, so we're going to use the bracket. We put the right-hand side in as minus sine x. Again, we have issues with this. That should say caps if it's in caps. It's not in caps, but it still gives me the capital X. So I go back, sort that out. Okay, watch those buttons over here if you can see where they are. Hopefully you can there. So be careful here. We put the division sign. Be careful when you put this in. Remember, it's cosine x plus 2. There's no bracket around x plus 2. So put the x plus 2. Okay, and we graph that. And that comes out like that. And then we're looking for the intersection here. Go to intersection, analyze graph intersection. We need the lower bound and the upper bound. And that's our solution there, which is pi 3.14. Let's now have a look at C. So the derivative of this function is the function itself times the derivative of what's up top here, the indice here, which is 2 cosine x. Rewriting that, we've got 2 cosine x times e to the 2 sine x. So that's pretty straightforward, that one. Now part 2 was equating the function to the derivative and finding the smallest possible value of x for which that equates to, the function equates to the derivative. So we end up with that. We've got this on both sides, so we end up with 1 over here. 1 equals 2 cosine x. That means a half equals cosine x. And from our trig ratio, the standard ones, we can see that that's there. That's cosine of 60. So the cosine of 60, x is equal to 60 degrees, or pi on 3 radians. Well, pi on 3 radians is 1.047. Therefore, x, which equals pi and 3 radians, is 1.05 to 3 significant figures.